Good morning everyone. Today we are going to discuss about CPU scheduling algorithm. So this is the CPU scheduling algorithm. So before going to discuss about this algorithm, we have to know about why CPU scheduling algorithm. So why we have to study this scheduling algorithm? So normally in a ready queue, so imagine that this is the ready queue. So in a ready queue, imagine that we are having only one process in the ready queue, and this is the CPU. So if there is only one process in the ready queue, that only single process will be executed in CPU. Suppose if there is a multiple process in the ready queue, P1, P2, P3. So likewise, if there is a multiple process in the ready queue, so which process will be executed in CPU first? So CPU will be getting confusion whether the ready queue, whether this P1 process has to be executed first, or whether the P2 process to be executed first, or whether the P3 process to be executed first. So there is a conflict. So CPU is in confusion that which process to be executed which is in the ready queue. So for that only the scheduling algorithm has been find. Okay, so based upon this scheduling algorithm, we can able to know, we can able to assign in the ready queue which process to be executed first. So here we are having many different types of scheduling algorithm. First one is first come first serve scheduling algorithm, shortest job first scheduling algorithm, round robin scheduling algorithm, and priority scheduling algorithm. Okay, so first come first serve scheduling algorithm means whatever the process which comes in the ready queue first. Suppose if P1 process which comes in the ready queue first, then the P1 process will be executed in the CPU first. Suppose the P4 process which comes in the ready queue first, then the CPU will execute the P4 process. So whatever the process which comes in the ready queue first, so that process will be executed first in the CPU. So that is first come first serve scheduling. Then next, shortest job first scheduling. So shortest job first scheduling means, so whatever the time which is given here in the process. So process which has the burst time or the process execution time. So for each and every process will be executed for a certain amount of time. So the execution time, whatever is very less in the process. Whatever the process has a very less execution time, so that process will be executed first. So shortest job. So shortest execution time process will be executed first. Then next, round robin scheduling. So round robin scheduling means each process which will be have given a particular time slot. Each process will be given with a particular time slot. Based upon the time slot, each process will be executed. So that every process will be given some time. So it will sometimes if some process has been given allocated for more time, if we give the other process we are not giving we are given little time. So what happen means it will take more time, the other process will be waiting for a long time. So here in round robin scheduling, each and every process will be given some certain amount of time for execution. So every process will be involved into the CPU execution. Okay, and priority scheduling. So based upon the priority, the process will be executed in CPU. So these are all the many different types of scheduling algorithms. So today we are going to discuss about the FCF scheduling algorithm and the shortest job first scheduling algorithm. So first we'll see about FCFS. So FCFS is nothing but first come first serve scheduling. So you all know that whatever the process which comes in the ready queue first, that process will be executed in CPU first. Okay. So for the first come first serve scheduling, so we are having a problem. So we have to solve this problem for FCFS. So the problem which has been given here. Consider the following set of processes that arrive at time 0 with the length of the CPU burst given in milliseconds. In question they have given the process, arrival time and burst time. Okay, so how many processes we are having here? P1, P2, P3, P4, P5. So 5 processes they have given in question. The arrival time of this process is, for P1 process it arrives at 2, P2 process which arrives at 0, P3 process which arrives at 2, P4 process which arrives at 3 and P5 process which arrives at 4. So this is the burst time. Burst time is nothing but the CPU execution time. So the P1 process will execute for 2 execution time, 2 times it executes. P2 process will execute only 1 time and P3 process will execute 3 times, P4 process will execute for 5 times, P5 process will execute for 4 minutes of time. Okay, so this is the execution time. Burst time is nothing but the execution time, how much time it takes for execution. Okay, so from this question we have to find out the average waiting time, and we have to find out the average turnaround time. Okay, the question will be given like this. So we have to find out the average waiting time and the average turnaround time. So we will solve this problem. So first we have to draw the Gantt chart for this. So when we draw this Gantt chart properly, so our 90% work will be done here. Okay. So first we'll draw the Gantt chart. So listen here. So what the question has been given, consider the following set of process that arrive at time 0. So the process will arrive at time 0. So what is where the arrival time of the process 0? So during the arrival time of process 0, which process has come at the arrival time of 0? P2. At the arrival time of 0, P2 process has been come first. So you have to write here as P2. So during the arrival time of 0, P2 process has been arrived. So P2 we have to write. So for P2 process, how much time it takes for execution? Only 1 time. So 1. So P2 process arrived at 0 and it completes its execution at 1. Then next check for the arrival of 1. So is there any process which comes in the arrival of 1? No. So in this arrival time there is no arrival of process. So here during the arrival time of this 1, the CPU will be in idle stage. The CPU will be in idle stage. So there is no arrival time of 1. So CPU is in idle state for 1. Then next, after 1 minute or after 1 slot, what happened means, just check what is the arrival time of the process in CPU. In the ready queue, that is 2. So here, during the arrival time of 2, there is a 2 process, P1 and P3. So 2 process which comes in the arrival time of 2. What are the process? P1 and P3. So if both these process comes in the arrival time of 2, so which process we have to choose? Whether we have to choose P1 or whether we have to choose P3. So during this time, what we shall do means, we can have the first come first serve method. We can follow the first come first serve method. So if the 2 process comes in the arrival time of 2, what we can do means, we can choose the P1 process. Because P1 process has been come first. So we can write here P1. So this P1 process, how much time it takes for execution? 2. the execution time for P1 process is 2. So here 2 plus 2 you have to write here 4. So this 2 plus the execution time of this 2 P1 process. So 2 plus 2 you have to write here 4. Then next the arrival time. So we have completed this P1. Then the arrival time of the another process, 2 arrival time, P3 process is there. So P3 process. So P3 process, how much time it takes for execution? 3. So P3 process, it takes for execution 3 times. Okay. So 4 plus 3, so you have to write here 7. Okay. Then next, so this has been completed. This has been completed. Okay. So what is the arrival time? The next arrival time, 0 arrival time is over. 1 arrival time is over. So during the 1 arrival time, this CPU will be in idle stage, and 2 arrival time is over. And the next 3rd arrival time. Okay. So during the 3rd arrival time, which process is executed? P4 process will be executed. So P4 process. You have to write here as P4 process. So P4 process, how much time it will take for execution? 5. So 7 plus 5, 11. Okay. So the next, what is the next process? 4. So for the 4 arrival time, which process to be executed? P5. So we have to write here P5. So P5 process, how much time it takes for execution? 4. So 12 plus 4, 16. So P5 process, which completes its execution for 16. Okay. So this is nothing but the FCFS algorithm. So here, when we add this, you will get 16. 5, 9, 10, 13, 14, 15, 16. Okay. So what we have to do means, so for P1 process, which completes execution at 16. Okay. So now we have to find out the completion time, waiting time, turnaround time, and the response time. So we have to find out the completion time, we have to find out the turnaround time, we have to find out the waiting time, and we have to find out the response time. Okay. So how you will find the completion time? So completion time is nothing but how much time the CPU will complete its execution. Completion. Now we have to find out the completion time, turnaround time, waiting time, and response time. So completion time. So how you will calculate the completion time? So every process, how much time it takes for it will complete its process. So imagine that the P1 process. So P1 process, how much time, at what time it completes its execution? P1 process, it completes its execution at 4. So you have to write here 4. Okay. P2 process, it completes the execution at 1. So you write here as 1. P3 process, it completes its execution at 7. So you write here as 7. and P4 process, it completes its execution at 12. So you have to write 12. P5 process, it completes its execution at 16. So you have to write 16. So completion time. So at each and every process, at what time it completes its execution. So you have to write the completion time. Then we have to find out the turnaround time. The turnaround time we have to find out by using the completion time minus arrival time. So turnaround time is nothing but the completion time minus arrival time is the turnaround time. We can also write the turnaround time as waiting time plus burst time. So waiting time plus burst time is also a turnaround time. So we didn't find out the waiting time yet. So we use this formula. Turnaround time equal to completion time minus arrival time. Okay. So turnaround time, how we calculate completion time? This is the completion time minus arrival time. So completion time is 4 for P1. So 4 minus 2, 2. Completion for turnaround time, completion time minus arrival time. So 1 minus 0, 1. 7 minus 2, 5. 12 minus 3, 9. 16 minus 4, 12. So this is the turnaround time. The next we have to calculate the waiting time. So how you will calculate the waiting time? So you all know turnaround time equal to waiting time plus burst time. So from this you can calculate the waiting time. So how you will calculate the waiting time? Waiting time equal to turnaround time minus burst time. Turnaround time minus burst time. So you already know the turnaround time. You also know the burst time. Okay. So waiting time equal to turnaround time minus burst time. So turnaround time is 2 minus 2, 0. 1 minus 1, 0. 5 minus 3, 2. 9 minus 5, 4. 12 minus 4, 8. Okay. Now we have to calculate the response time. So how we will calculate the response time? So response time will be calculated based upon, so if they consider that this is the first process. So first process, at what time it starts its execution. The P1 process, at what time it starts its execution, that time minus arrival time. So 2 minus 2, 0 is the response time. The next P2 process, which arrives at, it starts its execution at 0 arrival time. So 0 minus 0, 0. The next P3 process, it starts its execution at 4. So 4 minus 2, 2. The next P4 process, it starts its execution at 7. So 7 minus 3, 4. Then P5 process, it starts its execution at 12. So 12 minus 4, 8. So this is the response time. So here you can see here the waiting time and the response time is same. So it means that this is a non-preemptive scheduling algorithm. This is a non-preemptive scheduling algorithm. So in CPU scheduling, we are having two types of scheduling algorithm. That is, one is preemptive, and another one is non-preemptive. So this is a non-preemptive scheduling algorithm. So what do you mean by a non-preemptive scheduling? So non-preemptive scheduling is nothing but, we suppose a process which is assigned to a CPU. So if CPU is processing some process, so during that time the operating system, which cannot be able to forcefully remove the process, and it will allocate that process to some other process for execution. So the operating system cannot able to forcefully remove the process which is already executed in the CPU. So that is non-preemptive scheduling. It cannot be forcefully removed. So when it will be removed, after the completion of the process, it will automatically terminate. The process will be automatically terminated. Still that it cannot be forcefully removed. The operating system cannot forcefully remove the process. But here, in preemptive scheduling, what happens means the operating system, if it needs, it will remove the process which is currently executed and it will give the priority process. If suppose some process wants to be executed periodically based upon some priority, so that priority process will be executed here in preemptive scheduling. So if some process has been already executed, means that process will be forcefully removed from CPU and the priority process will be given executed in the CPU. So that type of thing is known as preemptive scheduling. So non-preemptive means it cannot be forcefully removed, and preemptive means it will be removed and it will be given priority for the other process and it will be executed. So this is known as preemptive and non-preemptive scheduling. So first come first serve scheduling is a non-preemptive scheduling algorithm, and it comes under the data structures of queue to execute its operations. It uses queue data structure for execute its operation. Okay. So now we have calculated the completion time, turnaround time, waiting time and response time. In the question we have asked that we have to find out we have to calculate the average waiting time and we have to calculate the average turnaround time. So how you will calculate the average waiting time and the average turnaround time? How you will calculate the average waiting time and the average turnaround time? We have to add. So first we calculate the average waiting time. Average waiting time. So average waiting time 0 plus 0 plus 2 plus 4 plus 8, 0 plus 0 plus 2 plus 4 plus 8 divided by 5. Okay. So you will be getting some answer is 2.8. So this is the average waiting time. Okay. Now we have to calculate the average turnaround time. Turnaround time. So we have to calculate the average turnaround time. So how will you calculate 2 plus 1 plus 5 plus 9 plus 12? 2 plus 1 plus 5 plus 9 plus 12 divided by 5 equal to 5.8. Okay. So this is the average turnaround time. Okay. The next we will discuss about shortest job first scheduling algorithm. So shortest job first, in the name itself we can able to understand that whatever the process which is having a very shortest job, so whatever the process which is doing very short job, so that process will be executed next. Okay. So here out of all available waiting processes, it selects the process with smallest burst time, smallest execution time, a process which execute a very smallest time. So that process will be executed next. Okay. So here by default it will be a non-preemptive scheduling. So non-preemptive scheduling means if some process which is executed in a CPU, that process which will not be forcefully removed. And the preemptive version of this shortest job first scheduling algorithm, we will call that as a shortest remaining time first scheduling algorithm. So by default we will be using this scheduling algorithm as a non-preemptive as a version. You can also have the preemptive version also. So that type of preemptive version scheduling algorithm, we will call that as shortest remaining time first scheduling algorithm. Okay. So now we will see an example problem here. So the question given here is, consider the following set of processes that arrive at time 0 with the length of the CPU burst given in milliseconds. Okay. So how many processes we have given here? P5, P1, P2, P3, P4, P5 process. Okay. So the average time of each process here given here is 2, 1, 4, 0, 2. And the burst time is nothing but the execution time. The execution time of each and every process is 15163. Okay, so the question they have given. So now we have to calculate from this, we have to calculate the average waiting time and we have to calculate the average turnaround time. From this problem, we have to calculate the average waiting time and we have to calculate the average turnaround time. So how we will solve this problem? By using the shortest job first scheduling algorithm. So first, we have to calculate the completion time. Okay, so first we have to draw the Gantt chart. Then we will calculate the completion time, turnaround time, waiting time, response time. Then we will calculate this average waiting time and average turnaround time. Okay, so first we will draw the Gantt chart. So how we will draw the Gantt chart? So when you draw the Gantt chart itself, almost everything will be done. You can be able to easily calculate all this. Okay, so first we will draw the Gantt chart. So Gantt chart. Okay, so the question which says the arrival time as 0. We are having the process that arrive at time 0. So what the process which arrive at time 0, which process will be arrived at time 0? P4 process. At the time of arrival, the P4 process will be executed first. So you have to write here as P4. During the arrival time of 0, P4 process will be executed first. Okay, so you have to write here P4. So this P4 process, how much time it will execute? Execution time for P4 process is 6 time. So you have to write 6. So 6 time it will execute and it will complete the process. Then next. So what is this actually? This is the shortest job first. So when we see here the burst time, so the burst time we have to check what is the shortest job. So that we have to give the preference. Okay. So the shortest job for this burst time here is this one and this one. So one is the very shortest job. So it will. So what are the process which takes very short time? P1 process and P3 process. But both of the process which takes equal time. So P1 process also takes 1 time. P3 process is also take 1 time for execution. So we are in a confusion. So which process to give the priority? So during this time, what we can do means we can follow the first come first serve scheduling. So who comes first? P1 process which comes first. Then only P3 process comes. So we have to give here P1 process. So P1 process, how much time it takes for execution? 1. So 1. 6 plus 1, 7. So you have to write here 7. Okay. Then next, this is P1 process. First come first. So P1 will execute first. The next P3 process will execute first. So next P3 process will execute. So P3 process, how much time it takes for execution? 1. So 7 plus 1, 8. Okay. So P1 process completes its execution. P3 process completes its execution. P4 process arrived. Okay. So what are the other processes we are having? P2 and P5. Okay. So now check what is the very shortest job here. What is the very less burst time? What is the very less burst time here? So the burst time for here, the process which takes very less burst time is 3. Okay. So 3 is the very shortest execution time. So that is 3 which process which takes P5 process. P5. So we have to write here P5. P5 process takes next. Okay. So P5 process, how much time it takes for execution? 3. So 8 plus 3, 11. So you have to write here 11. Then next, which one is the very shorter? This already completed as this is the arrival time. So this is already completed. So which is the remaining shortest job? 5. Shortest time take for execution is 5. So 5, that is which process? P2. So you have to write here P2. So P2, how much time it takes for execution? 5. So 11 plus 5, 16. So here you can able to see here in the Gantt chart, the CPU is not be in idle stage. CPU is continuously executing the process. At each and every time the process, each and every process is doing its execution. So during the arrival time, the P4 process which comes inside and completes its execution at 6, and P1 process which comes inside during the arrival time of 6 and it executes its completes its process at 7, and it completes its process at 8. P5 process completes its execution at 11. P2 process completes its execution at P6. So here the CPU is not in an idle stage. So at every time the CPU is doing its job. CPU is doing its process at each time. So here the CPU is not in an idle stage. So when we calculate the burst time of this, when you add this burst time, 6 plus 3 plus 9, 10, 15, 16, you will get 16. So the burst time will be equals to here. This you have to check this. So this will be, the burst time will be equal to this value. Okay. So now we have to calculate the average waiting time and we have to calculate the average turnaround time. So how you will calculate the average waiting time? You have to add all these process and you have to divide it by 5. So first we will calculate the average waiting time. Four plus 10 plus 3 plus 0 plus 6 divided by 5 equal to 4.6. So this is the average waiting time. Okay. So now we have to calculate the average turnaround time. So add all the turnaround time and you have to divide it by 5. So 5 plus 15 plus 4 plus 6 plus 9 divided by 5 equal to 7.8. Okay. So this is the average turnaround time. Okay. So by this way we can able to solve the shortest job first scheduling algorithm. Thank you.